So here we are doing page 2 of linear relations. So asked to graph the lines, and this is x is equal to 3. These are special cases. So let's find out where x is equal to 3. The easiest place is on the x-axis. There it is. X is equal to 3. Well, where else is x equal to 3? Well, x is equal to 3 right above that, and it's also equal to 3 right below it. And if you keep going down that line, x is always equal to 3. Y can keep changing. Y is constantly changing. And that is the line x is equal to 3. It's actually a vertical line. The slope is undefined. So I can look at that, tell myself I know it's a vertical line. The slope is undefined. If I remember that, which is convenient, then y is equal to negative 3. Let's find out where y is equal to negative 3. Well, here's the y-axis. Y is equal to negative 3 here. Where else is y equal to negative 3? Well, anywhere on this line. You could choose any point horizontally on this line. Y is equal to 3. X changes. X is negative, x is positive, but y is always equal to negative 3. That is a horizontal line. Put arrows on the end. Right, so y is equal to negative 3. This is a horizontal line. The slope is equal to 0. One way we can also think about this, y is equal to mx plus b. Well, if there's no x here, it's because m is 0. Because x is lots of things. So m is 0, and when m is 0, then that whole term becomes 0. So we're just left with y is equal to b. And so when we have y is equal to something, we realize it's a horizontal line. Alright, convert the following into standard form. Remember, standard form cannot have fractions. So let's remind ourselves about what standard form is. So let's look and see. Standard form is the slope-intercept. Slope-intercept, which everybody seems to remember, y is equal to mx plus b, because we learned that in grade 9. The standard form, all right, is ax plus by plus c equals 0. Now, I've seen it both ways. It can be that it's equal to 0, or this way, where it's actually equal to c. So we either have it equal to 0, or we have the c. And what c is just a number. A, b, and c are all numbers. A is always positive, and they're always whole numbers. Whole meaning it's not a decimal, it's not a fraction. So when I look over here, I see fractions. I don't want fractions. And I think to myself, well, how do I get rid of these denominators? Well, denominators are dividing. Opposite of dividing is multiplying. So how do I get rid of 2? I multiply by 2. But I can see kind of a shortcut here, because 2 and 4 are related. Why don't I try and get rid of this one first, and you'll see how it actually gets rid of both at the same time. So if I want to get rid of the 4, it's dividing, I want to multiply. The other thing I want to do is, sometimes people get confused when there's fractions in front. You actually can write these a different way and think of it as 1 times x. So this actually could be like x divided by 2, because I do the x times the 1. So the numerator looks like that, and the y times the 3, I actually get 3y over 4, and that equals 5. Those two lines mean exactly the same thing. So if I want to get rid of 4, I think I'm going to multiply by 4, and I'm going to do that to every single term. There's 3 terms in this. So I'm going to multiply by 4 by this term, and this term. So when I go 4 times x, that's 4x, divided by 2. And here, this is 4 times 3, but I want to think, why did you choose that? You chose that so that they would divide out. So I'm actually just left with 3y. And if you want to do the math, you can do 3 times 4 is 12, but then you can do 12 divided by 4 and you get 3 back. Do that on your calculator if you need to. And 5 times 4 is 20. I'm still not rid of fractions, but go back and look. Can I simplify this? 4 divided by 2. Yes, I can. 2 can go into 4 twice. So this is 2x plus 3y equals 20. So this is one version of standard form. If I wanted it to look like this one in here equal to 0, what I would need to do, I know some people think, how do I get the 20 on that side? The rule is always do the same thing to both sides. And you want to do the opposite to get rid of a term. So if there's no sign, there's a positive. So I'm going to rewrite that up here just so I can see it and you can see what I'm doing. That's a plus 20. Well, what do? I subtract 20, but whatever I do on one side, I must do on the other. So go ahead and do the 2x plus 3y. That doesn't change that because these are not like terms. I can't do any math. It just becomes minus 20. But on this side of the equal signs, if I have 20 minus 20, that ends up being 0. And that's your other version of standard form. On the test, you'll only have to do one. I would accept both. All right? But by looking down here, that wouldn't be in standard form like this. So let's make it look like that one. Other than the equaling to 0, everything's okay because there's no fractions. So I need to get rid of the 6. So what I want to do is I want to minus 6 on both sides. So here, if you like it this way, writing it on a line, that's 6 minus 6. So here I've subtracted 6 on both sides. This side doesn't change, it just stays the way it is. But here, 6 minus 6 equals 0. There is standard form. Right, so what are some things that we need to remember? Well, I've already written the 2 things here, slope, intercept, and our standard form. Okay. Slope is equal to rise over run. If it's up, it's positive. If it's down, it's negative. Now, what I tell my students is always go to the right, but to the right is positive. If you do have to go to the left, then the left is negative. So that's just for rise and run. So up, down, left, right. That's for slope. We probably should also write down y2 minus y1 all over x2 minus x1. Some other things to remember, a point is always the x and then the y. And here, this is the y-axis, this is the x-axis. If I drew a line, I'm just going to draw some line here like this. This is the y-intercept. This is the x-intercept. So if I write that here, that's the y-intercept. That is where it crosses the y-axis, and actually x is equal to 0 there. This point right here, that is the x-intercept, and that's where y is equal to 0. And there. I don't know what else you want to write, but maybe I'll think of some things to add in afterwards.